Thank you, Roman, for the introduction. So I'm Isaline from BRGM. I will present you today the pilot strategy project I have been coordinating in order to say some words from this project about assessing saline aquifers in Southern and Eastern Europe. So the objective of the main context for this project was to support the development of carbon capture storage in Southern and Eastern Europe. As you know, the main things happen in the North Sea. And so the idea is to unlock the CCS in these regions. And we have been investigating deep saline aquifers, especially because deep saline aquifers may offer large capacities for storing CO2. And we are especially looking at aquifers in the Lusitanian Basin in Portugal, in Spain in the Ebro Basin, in France in the Paris Basin, in Poland, south of Poland in Upper Silesia, and in Greece in West Macedonia. So the idea for this project is to prepare the ground for full and active development into production storage site, but at this stage it has been only research study and desktop studies, because this is a project funded by the European Commission under the Horizon 2020 program, and it was a research and innovation action. So we studied these 5 regions I've already presented, but we are 16 partners, so I'm coordinating the project from BRGM side, but this is a project that gathers the works from all these partners, and especially from 7 countries. 5 countries have case studies we are studying in these countries, and 2 countries, UK and Germany, have partners who not have case studies in the country, but they contribute with expertise to the project. So the French team for the project for the Paris Basin was BRGM, the French Geological Survey, and the IFPEN also, Geostock, Polavenia, and Simlog Institute for the Social Sciences. In Portugal, the team was led by University of Évora, together with University of Lisboa, and in Spain, in the Ebro Basin, was studied by the Spanish Geological Survey, ICME, together with CIEMAT and Repsol. In Poland, the partners were GIG, National Research Institute, and in Greece, CERS and HEREMA. This is a 5-year project that started in May 21, a long time ago, and finished last month. We had the final event in Brussels, and we had an entire day to present our results, and I'm trying today to show you an overview of the results in 15 minutes. Challenging. So objectives were to increase the maturity and readiness assessment of this aquifer storage in these 5 regions, to improve and to provide some detailed studies for these aquifers in this pilot sites we have selected, but also identifying and engaging relevant end users and stakeholders for the implementations of these new CO2 storage pilots, and propose development plans for these pilots. So this is a project workflow, classical workflow that address the study of the geological and technical feasibility of these pilots, as well as social feasibility, societal feasibility. So in parallel to the technical workflow, you can see, and I will develop, there has been also huge work done on the social sciences, SHS, in order to do some public engagement, community engagement, and stakeholders engagement. This work has been presented on Tuesday by Sven, so I will not focus on this today. I will focus on the most technical aspects. So we have been through a long process, starting from geocharacterization and geological models, carrying some geophysical surveys for some regions or data reprocessing, sedimentological description, petrophysical measurements, geomechanical and geochemical assessment in order to do some static modeling of the different reservoir complexes, 3D models for reservoir, cap rock, structural elements, porosity and permeability distributions as well, in order to do some dynamic simulation with the CO2 injection, to optimize the well location for our pilots and the injection strategy. Studies integrity of the new wellbore, of the cap rock, and faults and fractures, and studies the long-term the CO2 fate on the long term. And in order to provide some safety and aspects and performance for the storage sites and do the risk assessment, assess the leakage risk, so legacy wells, faults, cap rock integrity, the plume migration and seismicity. And finally, we ended up with proposing some concepts for the pilots and develop plans for well design, MMV plans, plans for capture, transport, and storage facilities, doing some environmental impact assessment as well, economic evaluation, and finally for some projects investment proposals, because the idea with this project is to provide all the studies that would be required to for an operator to apply for exploration permit in the area. So the idea is to provide the most elements as we can in order to make the things easier for a future operator. We the different regions did not go through all these steps, and mainly we can say that for France, Portugal, and Spain, we went all along the workflow. While for Greece, it was rather on the geological part, characterization of the potential of the aquifer, and Poland also was doing also the static modeling, but not as detailed studies as the others. So I will provide some quick insights on the different regions, but I will skip Greece because, for sake of time, we did not do any modeling. But for Silesia, the site is located so in the south of Poland. Two sites were initially considered in this area where some industry is heavy industry is present, so potential for CO2 capture as well. And two sites were considered, but at the end, the Radice, I don't know if I pronounced correctly, aquifer was selected because the recent law, the recent Polish regulations, authorize CO2 storage only in some aquifers or not in others. So this one will be allowed for CO2 storage. So the pilot concept the Polish partners have developed concern this Radice site with a potential capacity of 30 million tons, but in the pilot and 7 million tons are considered. With a pilot phase of 3 years, injecting 3 kilotons per year, and a potential commercial phase of 25 years with 300K per annum of injection. Some planning has been proposed for developing the pilots, including an exploration phase. Modeling has been done also for with the available information, and estimation of the cost for the pilot phase, also estimation for more commercial case. In the Ebro Basin, the site is located, in Spain, the site is located in the Ebro Basin. It's a looping structure, so this is how it looks like. So there is not much things in the area. And the targeted reservoir is in the Buntsandstein sandstones, and with 2 seals. And our colleagues from Spain have been studying also the outcrops from Peñarroyas to get data for this site, because they don't have much data on the site itself. So this is also an onshore site, 106 1,600 meter depth in hazard graben system, and there is a possible compartmentalization of the reservoir. So I put you here a map of permeability map, but you can see that there are some faults and so potential compartmentalization. But good seals and so the concept of the pilot here is to focus on the storage, propose some infrastructure on site, and 1 or 2 wells, depending on the case studies, because there are 3 cases that have been considered with capacities from, how do I go back? Here. With capacities between around 5 megaton, 10 megaton, and 20 megatons, depending on the compartmentalization of the reservoir, with 1 or 2 wells that have been considered. So the pointer is here to inject. The risk assessment has been done, and there are some questions about overpressure of the reservoir, so potential also induced seismicity. So for the pilot phase, there is no risk, but for more commercial phase, additional data must be considered in order to evaluate more precisely. And for next steps, a seismic survey should be conducted. And also for the business case, some potential CO2 sources has to be studied, including DAC for this region. Lusitanian Basin, so we'll try to speed up a little bit, is located offshore. So the only site that is located offshore, 20 kilometers from Figueira de Foz, in this Q4 TV1 prospect. This is an excellent reservoir quality with low active seismicity in this region, because it's not the case everywhere in Portugal, and conditions for storage are safe. They estimate around 90 megaton capacity, and so as you can see, there is also potential for emitters in the area. The storage complex is located between 800 meters and 1,200 meters depth, so 300 meter thick, with good porosity. For the pilot phase, the idea is to capture CO2 from a cement plant, transport by train, and transport then by ship to the injection site, and do some direct injection by ship for this first step of the pilot. But the idea is to grow up in a more commercial phase and to country scale, in order to link all the industrial emitters along the country with pipeline transport, and store everything in this area. Because this is a very low risk area with no critical scenarios identified. The plume remains confined in the reservoir because we had some doubt about the plume reaching faults or the abandoned well that is in the area, but it's not happening. And the cap rock also maintains good integrity. So there are some uncertainties that need to be further studied with exploration phase. Also, some cost has been evaluated, and with a total of 98 million euros. This is only for the pilot phase, and the idea is to say that it's not profitable evidently, because it's designed to reduce the risk and to reduce uncertainties. But for the Portugal side, the main critical risks are not really technical, it's regulatory, permitting, because for the moment the legislation is not ready for offshore storage and for CO2 transport, so there are some bottlenecks. and political and institutional readiness. And last but not least, for France, the Paris Basin, the case we are studying in the Paris Basin is located southeast from Paris, so you can see the Paris city here, and the site is here in a very agricultural area. So this is a green square here. The city in the middle is Gravaud, is an industrial area. The site is located between the gray polygons you can see are the current licenses for oil productions in the Paris Basin. So you see we have also a lot of historic of underground exploitation. The reservoir is in the Dogger formation, so it's a oolitic carbonate reservoir, deep between 1,600 to 1,700 meters, very thick, temperature of 60 degrees. And the cap rock is very thick also, with potentially 2 cap rocks. So the Mars, 100, more than 100 meters of Galovox found on Mars. So in the Paris Basin, we had a seismic campaign. So this is the only case we acquired some new data. And we addition this to all the historical data sets we have in the Paris Basin with a lot of wells that have been drilled. And this gave us a nice seismic cube and nice maps for the reservoir top. It's not really a structure, it's very flat area. So there is no faults, there is no real structure identified here, it's just a flat reservoir. We have done some modeling of injecting a pilot case, 100 kiloton, and a commercial case, 300 kiloton per year during 30 years. And there is absolutely no problem for each case. We have been studying the quantity also of CO2, plume expansion, dissolution of CO2, residual trapping, and in order to estimate the long-term fate of the CO2 injected. So for the risk assessment, as I said, no faults where we have no major risk identified for the pilot scale, and for commercial scale, potentially a risk regarding the legacy wells, because we have many legacy wells, and the plume may reach some wells. So it's not a saturation map, it's only the probability of the CO2 reaching these cells. So there is, in some cases, possibility of reaching the wells. So, and we have very few information about these wells. It was exploration wells in the 17th. So potential risk to be studied further. And we made some economic evaluation to assess the cost of these pilots on the pilot scale. The main thing we had is that we studied this site because we had a potential emitter with a fertilizer plant just in the middle of the zone that would have been a good provider for CO2 for the pilot test. But this plant has announced that it will close, so we will not be able to use this CO2 anymore. So we will have to rely on importing CO2, buying CO2 at least for doing the test. And the potential way forward for this work is that the exploration permit has been filed by a Dutch startup on the area, but they have a very long delay in processing the request. And no, for 2 years now, it has not been opened to public consultation yet. So challenge from the regulatory point of view. Some takeaways. Yeah. So this project provides some promising storage sites for CO2 storage in Southern and Eastern Europe. And this also provides the potential for decarbonizing local or national industry. So not relying on big infrastructure, but maybe on small-scale scenarios. But we need clear political support and funding to move forward with the storage de-risking through some pilot tests. And yeah, as I already said, some regulatory risk and long permitting delays that are still challenging. So sorry for being too long.
Thank you very much.
But yeah.